IGCSE Computer Science, Syllabus Statement 1.3.3a. Describe the principles of operation of 2D scanners and describe how they are applied to real-life scenarios. So, this is the first part of input devices. Now, I decided to have one video equals one input device because it's a little bit easier to find a specific input device that you want, and the videos are much shorter that way. However, there are going to be more videos, so keep that in mind. But they don't, like, if I split them up into these small parts, they don't take me that long to make. They only take me about 10 minutes to make. So, well, as opposed to an hour or two for a normal 10-minute video. Well, an hour plus a lot of breaks. But anyway, let's go ahead and get started with this. So there are quite a lot of devices that we have to cover in this topic, but hopefully we'll get through, I guess. Alright, so, yeah. A 2D scanner is, I'm pretty sure everyone knows what it is, or has heard of one or used one, and it's pretty much something that can scan or input like a physical object, usually paper documents, and storing them in a computer in an electronic form, such as a PDF or a JPEG. A scanner kind of looks like this. So, an example of the use of a scanner we're going to get to later, but like scanning passports at airports, and we're going to be discussing that towards the end of the video, when they apply to real-life scenarios. So here's how a scanner works. The document is placed on the glass panel of the scanner. A bright light is emitted, illuminating the document, usually from a xenon lamp. A scan head is moved across from under the panel, scanning the document. Now you can kind of see that if you ever scan a document without the lid covering it, you can kind of see this light move across the panel. That's pretty much the scan head, which is moved across. And an image of the scan is produced and sent to a lens using mirrors, and the lens focuses on the document image. The focused image falls onto a CCD consisting of integrated circuits etched into silicon. The CCD is made up of thousands of light-sensitive elements, which produce electrical charges when light falls on them. The scanned image is now turned into an electronic form, which software can produce an image from. So, for example, if you scan a document such as a textbook cover, for example, I don't know what I thought of that from, then you can get an electronic copy on your computer of that image. Now, computers with OCR software allow scanned text to be converted into a text file format. So basically, if it's, say, a page from a book that you scan, then OCR can look for these letters in the scan or the file, and then you can use it to, like, for example, change or copy text. It's quite useful. So the scanned image now can be changed by importing it into a word processor. If the document is an image file is formed, such as a JPEG file. So here, let's look at the uses of 2D scanners. So as said, they can be used in airports to read people's passports. And OCR software can be used to change or copy text in an electronic form of the scanned passport. And the photo in the passport is also scanned and is stored as a JPEG file, although not necessarily only a JPEG file. Just an example. Photo of the passenger's face is also taken at the airport, and it's compared with the image in the passport. So this is how it works. When the two images are compared, software will check the distance between the eyes in both images, the nose width, the shape of the cheekbones, the length of the jawline, and the shape of the eyebrows. So this is all for security, pretty much, in an airport. if they want to check that you are the same person from the passport that you're using, just to make sure that it is actually you and that you're not stealing somebody's passport, then they will do that just for security.